All right, trigonometry. I believe this shows up in our syllabus list as 5.1. It comes out of a book that has pre-calc A and pre-calc B in it. So the pre-calc B stuff is chapters 5 to 8. 5.1 is on angles. Math 54. Lecture 1. A little bright, dim it a little bit. Whoa. I think they want to do that scale very slowly, doesn't it? There we go. Okay, so we've got a couple things going on. In mathematics, we call a line anything that's straight and goes on in both directions. Think now. This is a line. If it only goes one direction, it has a starting point and goes on infinitely in another direction, we call it a ray. If it has a start and a stop, we call it a line segment. What's the terminology we got to get through to get to the exciting stuff? If we have two rays that start at the same point, how far apart they are spread. This how far this spread is called an angle. And we often use this character right there. Kind of looks like an Easter egg that you crack open with shit inside a Pokemon ball, if you like Pokemon. Is the Greek letter theta. Where rays have a point at the end of the line, or line segments have a point at both ends of the line, all three of these things are called endpoints. Missed that a second ago. Then when we have the angle, these are called the sides of an angle. Sides of theta is that side and that side. And where the two rays meet, we're going to call the vertex of the angle. Process that. So we have two ways that angle thing can be generated from. And I'm deliberately making them at different spreads or different angles. The measure, how we measure it is starting how we measure angles. Is we start from one side of the angle. And measure the rotation to the other side. Pause a little bit and let everybody write it down, process it. If I'm going too fast at any point, let me know. On most days, we have time to make sure we're going at a comfortable pace for everybody. In my head, this is like, you know, when you've done something a lot, it just becomes second nature. And you don't really think about it as much. But to someone else, it's like completely foreign, like if you play the guitar and you're really good at it, you can just pick up the guitar, start jamming. For me, that's math. If you handed me a guitar though, I'm gonna be like, it's just gonna be out of tune, it's all shit. And I need instructions slowly. And the person that plays the guitar quick does not necessarily take me slowly. So slow me down if I go slow. So we have two ways we can measure it. I can start one way and go counterclockwise. This is called counterclockwise. Or I could start from this side and rotate that way, and this is called clockwise rotation. And it's based on the way the hands on an analog clock like we have in the back of the room, how the hands turn, they go one direction. So we call it, when it goes counterclockwise, we will say that the angle is positive with counterclockwise rotation. And for clockwise rotation, the angle is negative. This bothers the shit out of me. I don't know why we made it this way. I'm sure we came up with this topic before we came up with clocks like that. But I don't know why we made clocks like that, not just keep up with the way math goes and make it like spin backwards. Because the clock can go either direction, there's no reason to make it go one way. But this is how it is, so this is what we got. So we could have a positive angle or negative angle, so this is theta. Then going the other direction. Going the other direction would be negative theta. And how do we do this? So like when you're like measuring something that's straight, we could use like a ruler, stuff like that. They have compasses, contract, or. I don't know what they're called compasses. We're not gonna use one in here to do it. But there's always a device that does it, and we have a unit that goes with it. When we use a ruler in the US, we use inches. Other countries use centimeters on their rulers. For these to measure our angle or rotation here, we measure rotation with something called degrees. At least in chapter 5. In chapter 6, we're gonna use something called radians. And you're probably not going to like radians at first. Because you've probably all seen degrees before, I know you have, at least with temperature. The same idea, we put a little circle up above the number. It's measured differently on temperature, that's a measure of heat. And on angles is a measure of rotation. But radians, when you get to calculus next, the next class in the math sequence, which is probably why you're in here. is calculus, and a lot of the stuff in calculus is a whole lot better when you're using radians. Like you're gonna see the stuff, if your calculus teacher does it right, they'll show you some of the shit in degrees, and you'd be like, nope, not doing that. So that's for later though, this is later. And we'll walk through how they all relate. Everybody with me so far? See pins going, so I'm gonna pause for a little bit. Everybody catch up. Serious shit right there, when people cross their arms, that's generally a bad sign. Crossed arms or I'm done with this shit, or fuck it, or. Every once in a while, it's just a posture for comfort. You're leaning back, that's what I assumed it was. If you're like, I'm fuck this already, you're gonna have a hard semester. We haven't done numbers yet. Several people are still writing. If you aren't writing and haven't written at all, you probably want to. Even though I said that the videos go up. Process of writing, some people don't take notes. You suffer if you don't. The process of writing something, and listening to it and seeing it and all that is good. But having it like go through and channel out your body and write it down in your own stuff it really helps with learning. So if you're not a person that takes notes for any class, your grades are probably suffering because of it. And if they're not, they will at some point when you get to shit that's hard. Oh, you already know it all. Presumably, at some point, even if you know this stuff, at some point this semester, you will not know it. So you wouldn't need the class. Happy with it, you're looking at it at?
Yeah.
Okay. Then I reached out like closer to it earlier.
Yeah, I just started a little more late today, I didn't get to see, you know.
Come on, right?
Yeah.
Oh. I am slow as fuck to learn names. The more you talk, the more I'm gonna go, hey, what's your name finally? I'll eventually ask. I know I asked everybody the name on the first day, but that was 2 days ago and I've met like 200 fucking people in 2 days. And most people only spoke once. You know what I mean? People that speak a lot get a lot of attention and then I'm like, okay, I'm gonna remember you because I know you're gonna keep speaking, which is a good thing. I want you to participate. Right? Everyone good? Okay. What did I leave off? Greece, okay. So. Let's say. Oh, I didn't even talk about it. Something else I want to add to that. Let's add something else to this. One more thing. Whatever side that the rotation starts on is called the initial side. And whatever side it ends on is called the terminal side. Testing you on like most of the terminology, but like you're reading the textbook or looking at it or Here are the sources, at least you'll know what the hell we're talking about. Back to where I was. So. If this is my initial side. And I. Rotate all the way around, I'm going all the way around. And I get back to where I started. So like it starts and stops at the same spot. This entire rotation, a full circle. Is 360 degrees. That's the symbol for degrees. You've probably seen degrees F and degrees maybe C. Degrees F is for degrees Fahrenheit. We normally just say degrees when we're talking about temperature, but it's generally degrees Fahrenheit. Here it's just degrees. There's no additional word with it. If I were only to go halfway around. And I stopped here. Making that my terminal side. 1/2 of 360 degrees is 180 degrees. So that's a half circle. And if I only went a quarter of a circle. And I stopped there and I was pointing straight up. 1/4 of a circle, 1/4 of 360. Is 90 degrees. So 90 degrees is like. The corner of a square, a corner of a rectangle. The more fun terminology, one of them you definitely should know. Is right angle. A right angle. Right angle. Is 90 degrees. In fact. If it's a little bit less than 90. Or a little bit bigger than 90, I'm exaggerating a little bit, it can be a little hard to tell. If it's like 89 degrees, it can be really hard to tell that it's not 90. So, when we do 90 degrees and we're doing it by hand, you'll see it in pictures. To represent a right angle, we throw a box in the corner to indicate that this is definitely a corner like a rectangle or a box. And that makes it, that's like, we're sure it's 90 degrees with that symbol. That way, if you see the symbol, you know it's 90 degrees. For sure. This one right here, if I were to do this. It didn't go all the way up, 90 would be all the way up, right? All the way would be 90, so this guy has to be less than 90. It's gotta be less than 90 because it doesn't go the full 90 degrees. We call that an acute angle. What? You got the, what the fuck is he talking about, bud?
I think I know what the other one's called, but
What do you think it's called?
obtuse.
It is. So if it goes past 90 degrees, that would be past 90 or greater than 90 degrees. We call it an obtuse angle. And when I say angle. The word when I'm saying angle, if you see, this is the equivalent of something called angle measure. Fancy, like pure mathematicians like to go by official terminology and they'll call it angle measure. But most people call it the angle, so. Just like we generally don't say degrees Fahrenheit, we just say degrees. Why say all the long shit when the first part says no? Says not. That. I don't even know what that terminology is. Straight angle. What the fuck's a straight angle? Huh. I'm gonna look that up later. It's apparently not. There's a word, and there, you would think a straight angle makes it sounds like it's just doing a line. Like 180 degrees. And that might be what it's going with. They might call that 180, but I don't wanna confirm that because I'm not confident with it. It makes sense to me that this 180 degrees would be called a straight angle. It is, alright, I'll take your word for it. I don't think it's important. It's so unimportant to call that 180 degree angle straight angle that your teacher didn't know what the fuck straight angle was. That's how important that is. 180 degrees is enough. You say it's 180 degrees, it's known. If you know angle, you know it's straight. So sometimes we've got a lot of angles going on and we'll use like theta. Often isn't what we want to use. Sometimes when we're like, let's say, as we'll be doing later, we're looking at triangles. Later. But. They'll initiate the talk right here. Triangles have 3 points. Usually we give the points capital letters to call what they are. I might call that A, B, and C. For the points. So when we do, like on a shape like this, generally the angle there is the name of the point. That's angle A. This is angle B. And that's angle C. That way it's easy to know what angle is going with what point. Because they got the same one. So each of these is a vertex of a triangle, A, B, C. Are each a vertex of a triangle. Name the angle with them. That vertex after the point. That's what I said, but I hadn't written it down, and people that like to write what I write and find it harder to write what I'm saying, because it is harder to write what I'm saying, because I'm just fucking running my mouth. It's hard to keep up with someone running their mouth. I don't know how people that do dictation, that's some hard shit. People talk fast. We're definitely gonna do a lot with triangles later. Plural of vertex. Here's your Jeopardy fucking question for the day. Does anyone watch Jeopardy? You do? What you doing to watch Jeopardy? You don't for that shit. Have watched it is, yeah. Unless you're hanging out with like grandma all the time, grandma's usually love what. Older you get, the more you enjoy that shit. The plural of vertex is vertices. So if I say vertices, I'm talking about more than one vertex. And you will hear that in other classes, in math classes as well. And let me pause for a while. To everyone can see this. You can sit here in your space. I would sure you're gonna ask me later, like, no, I don't know most of the people's names, even though I asked if I didn't recognize your face. I'm like, he looks. That, folks, is how you ask a class or ask the teacher something unrelated to the topic in the class. During lecture, you wait till he obviously is paused, and it's going to be paused at what? Approved. Some people will like walk right out, I'm like talking, like lecturing, and like. It hasn't happened this semester yet. But it will, it's still early. Someone will walk in the class while I'm lecturing, walk right up. Is there a spot to add, like? Really? You couldn't wait till I'm done speaking? It happens every semester. It hasn't happened yet. I think I just jinxed it. I think it will, if not today or tonight, this class later on. Or, I don't know. This is the first semester I've actually had Davids as students. You would think, with David being such a common first name, at least a white boy's first name, I would have had one by now, but I don't recall. No, I've had a David. It's been a while. No one ever called him David. They called him Weaver by his last name. That's why I'm not that. This isn't my first semester with David. Anyone still writing? If you are, raise your hand. Tell me, give me another second. All right, onward we go. So. If two angles. Add up to 90 degrees. We say they are complementary angles. And it's not spelled like pay somebody a compliment. It's slightly different. A compliment, that first E is an I when you give someone a compliment. And this, it's phonetically the same, it's all the same except a single letter. So let's say angle A. Sometimes they'll do this little symbol as an angle to represent angle. Sometimes represents angle. Well, if you see it, it almost always represents angle. But people don't always say it. Angle A plus angle B equals 90 degrees. Or you might see it as A plus B equal 90 degrees. And since they're adding up to a degree, it's implied that they're angles. They will say, in a circumstance like this, A is the complement of B. And or B is the complement of A. Still on the first page. I've got 4 pages, we're still on the first page, but all the other pages go quickly because they're all like math things. And this I've just been going over fucking terminology, like vocab, you're like, god damn. Are we gonna have some fucking numbers? If two angles add to 180. Gerard, or what are they called? Supplementary angles, it's a supplementary angle. That fucking band is soothing. It's almost too soothing, right? Does anyone else listen to like white noise, like fan or shit to go to sleep?
I mean, I have my fan on, does that count?
You have your fan on?
Yeah.
Yeah.
Same
It
thing.
doesn't have to be pointed at you, like having the fan on in winter is fucking psychotic. And having the fan on just to listen to the noise and it's pointed in a different direction just to hear the sound. A lot of people do it. Not very many hands went up, so either like very few people in here do it, or no one wants to raise their arm. Maybe I'm an odd duck, I know I'm an odd duck. Alright. So like in this case, we would say like A is the sun, A plus B is 180. A is the supplement of B. Bunch of math jargon. And we can say B is the supplement of A, but we did the same, I don't need you to write down for that. As long as you get the idea. Right?
Yeah.
How much do you actually wanna write down? Pictorially. We can have this be angle A and this be angle B. So A plus B at the 90 degrees there. And this. At some angle like that. And here A plus B equal 180 degrees. Alright, let's do an exercise. Sample. Angle theta equals. Let's go with 65 degrees. What is the complement of theta? And I'm gonna leave a little space and ask, what is the supplement of theta? So the first one, we can say something like theta plus question mark equals 90 degrees. Question mark, we could use as a variable. But theta is 65 degrees. So I'm gonna put theta in. And how could I find the value of question mark using stuff from like algebra?
Subtract 65 from 1.
Subtract 65 degrees from both sides, this is a nice little algebra step. And 90 minus 65 is 25 degrees. What about the supplement? Someone help me with this. What?
115.
115? Okay, how do you get that?
Subtract 65.
So. I'm gonna go back, I'm gonna call it letter B instead of question mark here. And you subtracted 65. And got B equals 115 degrees. That's it. Take a break in about 10 minutes. I know you're having fun, but. Pepe needs a break once in a while. I was running my mouth so much on Tuesday. Cause I have a class after this from 5 to 7. I was starting to fuck up talking about myself. How the fuck do you do that? You know? You missed a nice 45-minute introduction of me. Need up longer, say something, otherwise I'm gonna move on. Let's say we have this picture right here. That is a right angle. And I'm gonna say that this angle right here is 2x degrees. And this angle right here is 4x degrees. How do I find the angle, find angle x? Find the value of x.
Four x plus 2x equals 90 degrees.
That's a good way to go about doing it. We saw it's a right angle, we know they add up. These two are adding up to it. So adding 4x plus 2x, it should equal the 90 degrees. So what do we do with the 4x and the 2x?
If they're like 20 of them.
Since they're like terms, that's a good old algebra term, we can add the numbers in front. These are like terms. Throw a little bit of algebra reminders at you. So the numbers in front are called coefficients. Here's a really long word to describe something fucking super simple. Coefficients. And we add them. Just a little algebra reminder. So 4x plus 2x is 6x. And now what?
They want 90 by 6.
Divide 90 by 6, why? Right, but why? So we can get x by itself. We are a pack of wolves. And you wanna isolate your prey. Isolate that sumbitch, get it alone. That's why I went with wolves, not some creepy stalker thing. Wolves hunt by pack, isolate the weak one, the old one. So if I do that, what do I get? You get 15. And x degrees has to be 50, so in terms of degrees, it's 15 degrees. Can I confirm that? How?
Like, 15.
Yeah, I can plug it in and check it. You've got the, I don't know what he's talking about, look again.
It helps me learn.
Okay, as long as that's a learning phase, not a, looks like a thing. Alright, so if you're processing, we can always check our work. Well, not always, but very often in mathematics, we can check our work by plugging it in. I said 4x plus 2x equaled 90. If I plug in x. Does that equal 90 degrees? So when you plug something in, it's a good idea to plug it in with parentheses, especially if there's a negative sign there. Because you want to make sure you're treating it as a negative sign, not subtraction. And this is the same thing as 4 times 15. And in math, we use a dot, not the little x you learned in elementary school. Because x nowadays is for variables. What's 4 times 15? 60 degrees. And 2 times 15 is 30 degrees. And that does add up to 90 degrees. So we know the 15 degrees was correct. There's oftentimes, on many of the problems, you'll be able to check your work and see if it makes it a true statement. If this is not true, either you fucked up somewhere after you plugged it in, or you fucked up somewhere before it. You should, when you check your work. Always, and I'm gonna use fucking caps on this. Always go to the original equation. Because if you fucked up the first step. Like if I said 4x plus 2x is 8x. Then everything I got, my x value is based off the 8x. And it will match the 8x, but it won't work with the 4x plus 2x. So always go back to the original. Because you never know, you just might have fucked up step 1. Alright, what about? I don't know, let's go with. I'm gonna use y this time, 3y, and let's do 12y. If at any time something's confusing or you need me to restate something verbally. Or if you have a question and you don't understand something, please say something. A lot of students are uncomfortable asking, but if you ask, if you have a question, there's a good chance someone else in the room has the same fucking question. And you are being their momentary hero by asking. Cause they were afraid to ask, no one likes looking stupid, I get it, you're not looking stupid if you ask a question. That's the misconception a lot of students have. If you already knew everything in this class, you wouldn't be in this class. So, you're in here because you don't know it. So if something doesn't make sense. It's not gonna get any better if you don't ask. Ask. Ask, ask, ask. It's a good thing. Asking questions is a good thing. Unless you ask like 100. You can ask too many questions. How do I go about doing this one? We can add the Ys, what do I get if I add the Ys?
15.
180? Oh, you're jumping step, look at this guy jumping steps up here. Well, first off, I gotta add them together to get 15. And we divide by 15, and what do we get? 12. So let's check it real quick. If I do 12 times 12 degrees plus 3 times 12 degrees, oops, that's a 2. 3 times 12 degrees, do I get 180 degrees?
Yeah.
What's 12 times 12?
44.
Wow. Yay, people that respond, more than one person, more than 2 people, this is a good thing. It's gonna make the semester easy for all of us. Oh, what's 3 times 12?
36.
And you may not recognize that that does add up to 180, but if you do put it together, you're gonna get 180 equals 180, check mark. Y equals 12 is good to go. Alright, let's take a 10-minute break. Let me hit pause on the recording so it's not just sitting there as dead air. Sometimes I remember fun because that's what happened here, right? Having fun?
Yeah.
Spencer over here, he had me for stats last semester. His class had so much goddamn fun. They all came back on the last day after the final was over to have a fucking 2-hour party with me. Like 75% of the class showed up for a fucking party they threw. That's called fun. Alright, let's keep going. So, before I get down to that thing, we have the whole 90 degrees, right? So this is like 12 and 3 on a clock, right? So if we look at 1 o'clock and 2 o'clock on a clock. We still have to have A, B, and C add up to 90 degrees. But they're all equally spaced. So A equals B equals C, I don't know why I'm going through all this thing. I could write this as A plus A equals 90. So I have 3A equals 90, and I get A equals 30 degrees. An hour on a clock is 30 degrees. Does that make sense? I wish I hadn't used a clock as an example, because now I want to break it down. Alright, so. How much time elapses between when the hand moves that much on a clock, the minute hand? What?
30.
5 minutes. There's 5 minutes between 12 and 1. So it's easy to not think about, this is actually 5 minutes of time. Cause I'm really wanting to show you how small a degree is. But that's 15 degrees, or 30 degrees. Which means each minute on the clock. is we've got 30 degrees, we've got 5 minutes. Each degree is 6 minutes or 6 degrees per time minute. I'm calling it a time minute for a reason. Just bear with me. 6 degrees is just a single fucking, that's this. That's just a little tiny little thing, that's 6 degrees. So you can imagine how small 1 degree is. If 1 minute on the clock is 6 degrees, then 1 degree is like super small, but there's always something that's smaller. What if we only wanted a half a degree and stuff like that? What if we wanted a fourth of a degree? So we break down degrees even smaller. No matter how small a degree is, we can use smaller things. It's not small enough. And I'm gonna show you why. What if? Ooh, let's talk about warfare. Warfare. We got a tank here. And it shoots a cannonball. I was gonna go with missile, but let's go with cannonball. Let's kick it old school. The angle, this is making an angle off the ground. The cannon arm tips. It has a different angle. If it's 30 degrees or 29.2 degrees, it doesn't, oh, let's go with 29.8 degrees. It doesn't seem like a lot visually when you think about it. Maybe cannon isn't good because the cannonball doesn't shoot far enough. This is gonna be a missile. This is gonna be a missile, because missiles go really far. That's the important part. So let's look at it from like that angle right there. Let's say that's the actual angle, the 29.8. And 30 is just a smidgen over. Okay, if this keeps going in a straight line. The further that missile goes, the farther off target it is. And pretty soon you're not hitting the target, you're hitting a fucking school filled with children, and you're committing a goddamn war crime. Okay? Angle matters. They do navigation on boats by degrees off of true north. We'll do this later on in the class. If you're off by just a little tiny bit of a degree, but you're going across the ocean, you're gonna miss the town you're heading for. And may not even have the town in sight and not know where you ended up. So like long distance, those small things matter. That's all to motivate how we break down degrees. So 1 degree breaks down into smaller parts called minutes. 1 degree equals 60 minutes. Like an hour. The notation we use for minutes is a single apostrophe. And you're like, that's gotta be small enough, 1/60th of a degree, that's pretty small. A degree was already small, 1/60th of a degree has gotta be super small, one minute is super small. But we go smaller, because if you're good, like maybe we're not aiming for something on Earth, now we're on a trajectory to Mars. And being off by even like a half of a minute, we completely overshoot and miss Mars. Or undershoot and lawn dart into the fucking planet. So 1 minute breaks down into, guess what a minute breaks down into? 60 seconds. So it's so much like time, why didn't they just call the degrees hours if they're gonna do this shit? 1 minute equals 60 seconds. So that's the symbol for seconds. That's the symbol for minutes. That is the worst tank I've ever drawn. I've drawn a lot of tank, like when I was in elementary school, they made us like do a lot of art and like we had to even make our own little magazine. I had little tanks and robots and fucking shit in it, and I had tanks, but that was the worst. I'm trying to sketch quickly, bad, very bad. It's even a worse missile. Right? For those of you that are using the My Math Lab or the Pearson thing for homework. If when you go to it and you try clicking on something, nothing happens. I'd be willing to bet that you have pop-ups blocked for that website. So depending on whether you're on an Apple or a PC or something like that, just Google, how do I unblock pop-ups for a website? It will walk you through how to do it on your computer. If you notice it right away when you do it, you click on it, something will pop up right on like the, I'll show you guys in a second. You should be able to right click on that and just click enable pop-ups for this website. But it's hard to simulate because pop-ups are enabled on this. But someone will have that problem. You can text me a picture of your screen when that happens, like, I don't know what happened, and I will show you like what, if you give me enough of your screen, I'll show you where it is on your screen then. As long as it's on an Apple, fuck Apple. No, I got an iPad this winter from the school so that I could make teaching better, and I just have not learned how to use it because fuck Apple.
You have an iPhone?
What?
You have an iPhone?
Nope. Why do I wanna pay fucking $900 for a fucking phone? I can do the same thing as a fucking $400 phone.
What kind of phone you got?
I have a Samsung Galaxy S20 FE. Yeah, I haven't upgraded for years. Why upgrade it when it works?
True.
Yeah, I'm on, guess what phone plan I'm on?
Cricket?
Right. Almost as cheap as, no, I think it's even cheaper than Cricket.
No way.
Mint Mobile,
I was gonna guess it, I should have guessed it.
Ryan Reynolds.
Yeah.
Yeah.
Is it? Like. Have it.
No, I got it because it was $15 a month.
Oh.
Unlimited minutes, $15, but that's fucking cheap. Why pay 60, you know, some of them are get really fucking expensive.
I got cricket,
What's Cricket at?
I mean, no, I paid 20.
See, 15's cheap, it's cheaper than Cricket. And he makes it funny commercials. Alright, everybody looks like they're done writing, I'm done distracting you with fun shit. Let's do some examples with this. EX is my what I write, for example. Alright, so let's say I have 28 degrees, 35 minutes. And I want to add to it 63 degrees, 52 minutes. I'm gonna stack them because that's how I roll. I add vertically when I can. I've got a 7, I've got an 8, I've got a carry the 1. I've got 91 degrees, 87 seconds, or 87 minutes. Minutes like on time, reset back to 0 when you hit 60. So for every 60 minutes is 1 degree. What I'm gonna do is I'm gonna peel off 60 minutes and add in 1 degree. So that'll go down to 27 minutes and this goes up to 92 degrees. I'm just swapping it for a different measure. Rather than saying 15 inches, I'm gonna say 1 foot 3 inches. Instead of saying 87 minutes, I'm gonna say 1 minute and 27 degrees. That's how you add, if your calculator does degrees, minutes, seconds. And you know how to use degrees, minutes, seconds on your calculator. I don't have a big problem with you using it. It's basic addition though, it's not too hard, it's. It's hard to fucking learn how to use some of these calculator things and it's just do some basic shit.
How come you subtract 60?
Because we want minutes to be between,
Oh, I get it.
well, I'll finish in case if someone else didn't get it. We want minutes to be between 0 and 60. Well, really, 0 and 59. Cause if we're up to 60, we got a full minute, and why do that? Kinda like on the clock, when it's let's say it's 10 PM. Or 10 AM, when we add 3 to it, we don't say it's 13 o'clock unless you're doing on military time. Military time does the whole 24-hour time period. At 12, we reset and go down to 0 and it goes up to 1, and the next one will be 1. 10 AM in 3 hours is 1. Same idea with this, but not like a 12, but it's 60. That makes sense? Everyone good with that? Let's do one with subtraction. Let's go with 51 minutes, why not? Now, if I try to line this up underneath this. I don't have anything to subtract the 51 from. The way I have it set up. So what I'm gonna do is 180 is 179 plus 1, right? And I can turn that 1 degree into 60 minutes. So I could say 180 is the same thing as 179 degrees at 60 minutes. And then I can subtract the 117.51 off of it. Very much like making change on the dollar, but we don't have 100 pennies, we've got 60 minutes. Does that make sense?
You say how that's not again with the pennies?
Yeah, like if you had $1 and you needed, like, fuck you, if you've ever worked as a cashier. And if the machine didn't tell you what the change was, like old cash registers did, you had to work it out. Like $1 is 100 pennies, and if they spent 79. You owe them the difference between the 79 pennies and the dollar, you would do 100 minus 79, you get 21. You learn to do math with coins quickly when you work with coins. Like you'd be like, that's 2 dimes and a penny, or whatever you said. The same idea here, we're not breaking it down into parts of 100 like we do pennies. We're breaking it down into 60 because that's what a degree breaks down. Yeah. I'm just I picked 2 angles and one to subtract the other.
Oh,
I randomly picked a number. The idea here is to look at the operation and see what happens. Now we can do subtraction like normal, like 0 minus 1 doesn't work, so I could borrow 1. Make that 10 minus 1, get a 9. 5 minus 5 is 0. 9 minus 7 is 2. 7 minus 1 is 6. And 1 minus 1 is 0. We've got 62 degrees, 9 minutes. This is the same in value as 62 degrees, 9 minutes written like that. But it looks funny. You're better off having 2 decimal, like do the 2 decimals, not decimals, digits. Put it in the zero if it's a single digit minute or second, it looks better. It's not wrong, but it looks better. Any questions? Alright, so working with degrees, minutes, seconds can suck. I think you can see that already. Sometimes we like to use, and often. Like navigation uses degrees, minutes, seconds. On a boat, shit like that. Navigation goes by that. We like to use decimals, so if we don't want it like a decimal degree. Like we can turn this into. We can go, it's called DMS for degrees, minutes, seconds. In fact, if you have a calculator and it has that option on there, it's probably indicated by DMS. We can go to decimals. So let's look at how that happens. Let's say we have 62 degrees. 12 minutes. And I don't know, 45 seconds. We want to write this as a decimal. So I don't know if you ever learned this whole. This operation, what we're about to do is called unit conversion. Converting between different types of units. Like inches to feet, stuff like that. So if I want to take the 12 minutes and convert it to a decimal. The way you can do unit conversions is we want to get rid of minutes, put it on the bottom. And we want degrees on top. That's what we're aiming for. We want to get rid of minutes. So shit on bottom. Or what we don't want on bottom. And the units we want on top. Then you write the relationship between them. The relationship between them is in the form of numbers. 1 degree is 60 minutes. And this is like a fraction. So you're gonna treat it like a fraction. And we're multiplying it. And if you've forgotten how fractions work, you multiply tops and you multiply bottoms. That's 12 minutes, this is 1 degree, 60 minutes. The minutes parts cancels. And we've got 12 times 1 on top, 1 times 60 on bottom. This is 12 degrees over 60. Which ends up being 0.2. I think that's 0.2.
0.2.
Yeah, it breaks down, it shrinks down to 1/5. We're gonna do the same thing with the degrees, or the minutes, seconds. So we had 45 seconds. I'm gonna throw seconds on bottom. And the only one that I know a relationship with is minutes. 1 minute is 60 seconds. But I don't wanna end up with minutes, I wanna end up with degrees, so I'm gonna make another bridge. And I've got 60 minutes equals 1 degree. Seconds cancel there, minutes cancel there. Our end result is 45 times 1 times 1 over 1 times 60 times 60. That whole number is a number over 1. Now, if you're gonna put this in a calculator. In a calculator, you would do 45 divided by, if you do divided by 60 times 60, you're gonna get 45, which is gonna be wrong. If you've got a parentheses key, use a parentheses key, 60 times 60. Or do 45 degrees, or 45 divided by 60 divided by 60. On a calculator. Because otherwise you're fucking up order of operations, the calculator's gonna spit out, you should know that 45 divided by 60 and another 60. Is not gonna give you 45 back again, so you'll know you've done it wrong on that one. Or you can pre-multiply the 60s. Is 45 over 3,600. And then divide that. And as a decimal, that is 0.0125. And now we're down to degrees, that was the amount we were looking for. So we had 62 degrees, 12 minutes, 45 seconds. That's the same thing as 62 degrees. The 12 minutes was 0.2 degrees. And the 45 seconds was 0.0125 degrees. This equals 62.2125. They do it, I don't know why they focus on this so much in 5.1, you're gonna use this so little. In the big scheme of things. But people are familiar with degrees, they've seen it in elementary school. Usually, they're a little a little. They look like that. Protractor, is that what it's called? I would say compass. Protractor. You can use that to, like that's how they do it. Let's go the other way. Let's go from decimals to DMS. So let's say we have 85 degree or 85.263 degrees. I'm gonna peel off the part that is a decimal and write it like this. This is the true thing, they add together to make the same thing. 85 is where we want it to be, this 0.263 is not. So I am gonna, like, I want it to go down to minutes. Or I want minutes, I'm dumping degrees, so I'm gonna put degrees on bottom, minutes on top. That way the degrees get dumped. There is 60 minutes to 1 degree. And if I treat this like a fraction times a fraction. This is 0.263 times 60 minutes. And what do I get when I do that? So that is. I still have my 85 degrees. And this 0.263 is 15.78 minutes. 0.263 times 60 was 15.78. Unless I fucked that up. Then we're gonna do it again. We're gonna peel off the decimal again. So this is 85 degrees plus 15 minutes plus 0.78 minutes. And we're gonna do the dump the minutes and go to seconds here. And again, we look for that conversion rate. There is 60 seconds to 1 minute. So 0.78 times 60 seconds. I'm getting 46.8 seconds. So the 85.263 degrees is 85 degrees, 15 minutes, 46.8 seconds. Do you have a question? Oh, your arm's on the chair, relax. Okay, your arm in the air, asking questions. And generally, we round to nearest full second. So 46.8 rounds up to 47. If you don't remember how to round, we've got 46 point, I'm gonna say X right here. If X right there, that X right there is 0 to 4, you round down, which means drop it. That would turn to 46. And if X is 5 to 9, we round up. And so the 46 bumps up to 47. There's a quick recap on rounding. Rounding is one of the easiest things you know how to do. You would be surprised how many people fuck up rounding. Stats class, and then when you take math 21, a lot of the homework is they're constantly fucking rounding to a decimal place. And the computer will not tell you if you rounded wrong. That could be your only mistake. You can do everything else right and round wrong, and it's just gonna tell you you're wrong. And you're like, I don't know what I'm doing, I'm a moron. No, you just round wrong. It's the most common mistake in stats. If this feels easy, don't worry, it'll get hard, I promise. Is ready for more? Nope, people still writing. Quit rushing people, Jones. So think about this whole navigation idea for a second. Let's say we're driving a boat. There's 360 degrees we could travel. If I just say I'm going 79 degrees in the direction, that doesn't mean anything unless you know which direction 0 is, right? So knowing which direction 0 is very important. In mathematics, Let me pause for a second, people are still writing what I had before. Mannix. We show the 0 degree direction. Straight to the right. That's 0 degrees. So if we put this on like a graphing grid. Like if this were. When you're doing algebra, you do a lot of graphing. If this were the y-axis and this were the x-axis. 0 degrees is in the x-axis, positive x-axis direction. And we said positive angles go counterclockwise. So going back all the way up to the y-axis, this would give us a right angle. So the y-axis is at 90 degrees. So any angle in this entire region is between 0 degrees and 90 degrees. That track? We call this area quadrant 1. They usually use like some Roman numeral shit. And use Q1. If we went around and went to the other side, we know it's the supplemental angle going straight to the left is 180 degrees. So we keep adding 90 degrees as we rotate to another line. 180 plus 90 is 270 degrees down here. And if I go back around, I do a full circle, we have the 360, so that's also 360. So we say an angle is in standard position. If the initial side starts on the 0 degrees. Or on the positive x-axis. If this is 0 to 90 and these are 90 to 180, any angle in this area over here has to be between 90 degrees and 180 degrees. This region is called quadrant 2. This region, theta is between 180 and 270. We call this quadrant 3. Roman numerals. And 270 to 360 is in quadrant 4. That's a lot to process, so I'm pause, give me a second. Just download. It's an angle, it's, they're all angles. They have a special name for the angles that falls on an axis, which I'm gonna say next. And I will never probably use the word again. It's an awkward word to say. What you're asking now, the 0 degrees, 90 degrees, 180 degrees. 270 degrees, 360 degrees, we could keep going around. Any angle that falls on an axis. Is a quadrantal angle. And you probably never hear me say that word again. They don't say it's in a particular quadrant. Those angles aren't in a quadrant. They're like the boundaries of quadrants. If I went around again and added another 90 degrees to 360, like if you're winding something up, you could do more than one lap. The next one, 360 plus 90. Would be 450 degrees. When two different angle measures or two different angles. Are actually pointing in the same direction. They are called coterminal angles. Get to that once by just going and doing 45 degrees. Or I could go all the way around and this would be 360 plus 45. Is 405 degrees. 45 degrees and 405 degrees are coterminal angles. So they differ by 360 degrees or multiple of 360 degrees. Got some examples for coterminal angles, and then we're gonna just do one line word problem, we'll be done. Several days will be done early, today doesn't look like that's happening. I don't know how early we'll be done on other days, but usually we're done early, we'll by a little bit. Those of you that have been writing, you can start working on figuring out. What is the smallest? Positive. Coterminal angle. Let's say A is 1,106 degrees. I'll look at negative degrees, maybe I need to draw what negative degrees are on there. For B and C, I'll draw like a sketch what negative is in a second. But this part is the same. So what we're looking, the smallest positive one is gonna be between 0 and 360. That's just like in the first loop around. So one way to get it is either you keep adding 360 or subtracting 360. If it's too big, we gotta keep subtracting 360. If I subtract 360 once, this is 746 degrees. I can subtract 360 again. I have 386 degrees. I subtract 360 again, and I get down to 26 degrees. I have, only reason I did those so quickly is I have those results written down ahead of time. Otherwise, you just keep hitting minus 360 on the calculator, it goes through.
Yeah.
Calculator works good. For other ones, if it's negative, we want it to be positive, we gotta add 360. So this ends up being 210 degrees. Because negative 150 plus 360 is the same as 360 minus 150. Addition of a negative is the same as subtraction. We're gonna do that one on this one. At 243, negative 243. And we're still negative, so I'm gonna add another 360 degrees. And I get 117. So that's the smallest one for that one, that's the smallest one for that one, that's the smallest one for that one. I'm gonna illustrate B real quick. Rapidly. I know 210 degrees is past 180. Should be like this is 180, I need another 30 degrees. This is the angle 210 degrees. Going backwards clockwise is the negative angle, this would be the negative 150 degrees. So when you go backwards, this is negative 90. You're subtracting when you go clockwise. One more example. Back before we had solid state drives, we had disk drives. Or even better, if you go back far enough, we had the floppy disk drive. That's some old school shit right there. I don't even have a floppy disk anymore. So the way a disk drive works, you know, you got your CD or your DVD or some shit like that. And like information's on recorded on it, and this thing rotates super fucking fast. And that's how it pulls the data off of it. It's magic. Like a DVD player, like I think it fucking bounces light off of it and somehow that makes a movie. I don't know how the shit works. Technology, you know, whoever does technology is a goddamn magician to me. I don't know how my calculator works, I don't know how computers work, I know they do work. They let me play Dark Souls, that's all that matters to me.
Let's get this what?
Disk drive,
This goes.
and they rotate super fast. This is effectively a wheel. The wheel. So let's say a wheel makes 270 revolutions per minute. Through how many degrees? Will a point on the wheel, not at the center, rotate in 8 seconds? That's time seconds here. So inconvenient that they use minutes and seconds. And one of the most common uses is dealing with shit on the clocks and times. It's a pain in the ass. Why did it have to start at pointing to the right? Why couldn't it start pointing up like a fucking clock? If I could change the goals, something, little things like that. So we're gonna do our unit conversion shit again, not a whole lot of time here. I'm gonna start with 8 seconds. We've got 8 seconds on the clock. Now, a revolution is one full circle. Okay. I want to, when I end up here, I want to end up with degrees. I'm gonna use DEG to indicate that when you're talking about the angle stuff here. And like seconds here is gonna be time. I have information per minute, so I need to get rid of seconds. And end up with minutes. We have 60 seconds in 1 minute. And I can dump my seconds here. We're gonna keep building bridges until we get to where we want. I now have minutes, I don't wanna have minutes. I want revolutions. I'm gonna dump minutes in favor of revolutions. There was 270 revolutions in 1 minute. If it had it in revolutions per hour, we would have to go with hours, change the hours too. That allows me to dump minutes, and I've got revolutions. I didn't want revolutions though, I want degrees. A degree is a full circle. And a full circle one revolution is 360 degrees. My revolutions cancel out, I'm left with the unit I want. And we're gonna treat this like a fraction. I've got 8 times 1 times 270 times 360 on top. And I just have 60 on bottom. I'm getting 12,960 degrees. A lot going on there, right? If you've never seen the bridge thing, it's an easy way of looking at it, like throwing the shit you don't want into the fucking river below. You pollute. Other than that, that's it's 5 o'clock, I've held you out to a little bit long, sorry guys. GTFO! Or stick around and finish.